Hello students, let us start with part 9 of hydrocarbons. Addition of elements of hypohalous acid, halohydrin formation. Chlorine and bromine in the presence of water readily add to alkene to form halohydrins. X2 when react with water it gives HOX and HX. When alkene CH2 double bond CH2 it undergoes halohydrin formation, then it gives OH CH2 CH2Cl and HCl. The addition of elements of hypohalous acid take place according to Markovnikov's rule. CH3 CH double bond CH2. Now it is unsymmetrical alkene react with hypohalous acid HOBr. It gives CH3CH OH CH2Br and HBr. Take an example of propene. CH3CH double bond CH2 when react with bromine in presence of water it gives a bromohydrin, which is the major product. And let us study its mechanism now. What happens actually when Br2 it attack on the double bond of propene, it work as electrophile, and then one Br negative which is left and other Br it join to doubly bonded carbon. Now nucleophilic attack by water, and then water removes a proton which is fast process and it gives CH3 CH2 OHBr. Addition of sulfuric acid. Cold concentrated sulfuric acid add two alkenes to form alkyl hydrogen sulfates in case of unsymmetrical alkene. Addition occur in accordance with Markovnikov's rule. As is shown on the screen, CH2 double bond CH2 when it react with H2SO4, so it will replace one H and there will be attachment of OSO to OH, means SO4OH. All alkyl hydrogen sulfates on boiling with water undergoes hydrolysis to produce alcohols. For example, CH2 double bond CH2 in presence of concentrated sulfuric acid and water upon boiling it gives CH3 CH2OH. Overall two-step conversion of an alkene first into alkyl hydrogen sulfate followed by hydrolysis with boiling water to form alcohol is called indirect hydration of alcohols. Addition of water. Some reactive alkenes do add water in presence of mineral acids to form alcohols. It also takes place according to Markovnikov's rule. CH3C CH3 double bond CH2. It's a case of substituted alkene. When add water in presence of acid, there is substitution by one OH and other H adds to double bond. It means single bond is obtained. Oxidation reactions of alkenes. Number 1. Complete oxidation with oxygen or air combustion. Alkenes burn in oxygen or air to form CO2 and water. This process is called combustion. All combustion are highly exothermic. For example, CH2 double bond CH2, thrice of oxygen, it gives twice carbon dioxide and twice water. Controlled oxidation. Number 1. Oxidation with oxygen. When ethene add only half molecule of O2, there is formation of ethylene oxide. Now, oxidation with potassium permanganate. First, with cold dilute neutral or alkaline KMnO4. Because of the presence of pi bonds, alkenes are readily oxidized by cold dilute neutral or alkaline KMnO4 solution. to give vicinal alcohols. It is also called 1,2-glycols. The reaction is called hydroxylation. Since during this process, two hydroxyl groups are added across the double bond. So, reaction is when KMnO4 react with water, it releases nascent oxygen. This nascent oxygen in presence of water attack ethene. Then it gives diols CH2OH, CH2OH. Oxidation with ozone. When ozone is passed through a solution of alkene in some inert solvent such as CH2Cl2, CHCl3, CCl4 at low temperature, then it oxidizes alkene to ozonides. Ozonides are unstable and explosive compounds. Therefore, they are not usually isolated but are reduced with zinc dust midway the reaction. And then hydrogen or palladium give aldehydes or ketones or a mixture of these depending upon the structure of the alkene. Now, let us discuss this reaction. You are with an alkene. Add ozone in presence of CH2, Cl2. There will be formation of an ozonide. Ozonide, that is a closed ring type structure. Then treat with zinc in presence of acetic acid. There will be formation of two functional groups. In fact, both are carbonyls. One is aldehyde, other is also aldehyde. If the ozonides are decomposed only with water, then hydrogen peroxide produced during the reaction oxidizes initially formed aldehydes to the corresponding acids. Agonolysis. This two-step conversion of an alkene into an ozonide followed by its reductive cleavage to give carbonyl compound is called agonolysis. There are lots of reaction on the screen. Let us study the middle reaction. CH3CH, double bond CH, CH3. It will give mixture of the two same aldehydes, CH3CHO and CH3CHO. Reactions take place in presence of ozone, CH2Cl2 and zinc, water at temperature 196 to 200 Kelvin. Uses of alkenes. Number 1. Lower members of the family are used as fuels and illuminates. Alkenes and substituted alkenes upon polymerization form a number of useful polymers such as polythene, PVC, Teflon, Orlon, etc. Ethene is employed for the preparation of ethyl alcohol and ethylene glycol. Ethylene is used for artificial ripening of green fruits. Ethylene is also used in oxygen, ethylene flame for cutting and welding of metals. Thank you.